Okay, welcome to the second part here, which is chapter 7, and we're going to start talking a little bit about lines and angles, and this is something I just love doing. I don't know why, but I just love doing lines and angles, and I'm hoping it feeds off onto you guys, and you guys get kind of giddy over this stuff too. It's pretty basic actually, and once you understand it, there's lots of little rules that we can use that make it quite simple. And I'm going to make it part of your project for me here for term 2, doing all these different angles for me. So first off, angles in a triangle. A triangle we know is got 3 sides. And because it has 3 sides, it has 3 angles. So you've got an angle here, an angle here, and then an angle there. And so when you add up all those 3 angles, it doesn't matter what the triangle looks like, all 3 angles are going to equal 180 degrees, always, regardless. Okay? So I could have a triangle that looks like this. When I add those 3 angles together, they're going to equal 180 degrees. And so, how could you prove the angles in a triangle add to 180 degrees without using a protractor? Add them up. Okay? That's all you got to do. And so, and how would you find a missing angle? Well, that's when we would use a couplement. We could subtract. So if I have 2 angles already, I can subtract those 2 angles from 180 degrees, and then that will give me the remaining triangle. So for example, if I have a triangle like this, so let's say that this one is 85 degrees, and let's say this is 25. To find out what my blue angle is here, I'll go 180 minus, and then I'll add those 2 together. I don't have to, but it makes it a little bit easier. So it's going to be 180 minus, whoops, minus, so 85 plus 25 is 110. And that is going to equal 70 degrees. So this is going to be 70 degrees. So it's one way. The other way I can do it is to use a protractor. And I've got protractors in class that I can lend you. If you've got a geometry kit at home, dig it out, try to find your protractor. Now it's kind of hard to show you how to use a protractor here on this. So what I'm going to do is kind of flip my computer around a little bit. And I'm going to use a virtual protractor right here. But in order to make things move, I've got to be able to use my arrows. So I'm just going to hook up my keyboard here. And hopefully everything still works. So if I want, when we want to use a protractor, right there, we don't line it up on the bottom. Okay, right where my little finger's pointing, that is not where you want it to go. You want it to go right in the middle. Because if you line up down here, well, there's no numbers down here. You can see there's a 0 up here. Okay? So if I want to measure angle A, I'm going to line them right up like that. Right along the 0. Because I'm starting on 0, I'm going to count this way, going up. And so you can see that that goes to 70. So angle A is 70 degrees. Now, I can do it the other way. I can flip this around so that now this 0, I'm starting this way, this one lines up with the 0. And again, because I'm going to 0, I'm going to go this way. And again, 70 degrees. So you can use it either way. So let's find out what angle D is here. So I'm going to take my protractor here. I'm going to move it around. And again, I'm going to get this vertex right in the middle. Right like that. And so I'm starting at 0. And I'm going to go around. And that one's, angle D is 120 degrees. Same thing. If I wanted to do it the other way, I could. Put in the vertex. Line it up. So 0. So I'm starting at 0. You always want to start at 0. And I'm going to go around, and again, 120 degrees. It's not 60 degrees, because I'm going from 0. So I'm using the inside numbers, going to 120 degrees. So that's how we can use a protractor to figure out what our angle is. Okay? I'll just do one more. I'll just figure out what angle B is here. So I'm just going to turn this around a little bit. And put that right like that. Starting at 0, so I'm coming around, and that's 100 degrees. Because this time I'm starting at 0, so it's on the outside numbers. Come around to 100 degrees. So that's how we can use a protractor to figure out what a measurement of an angle is going to be. That's going to work every time. So come see me if you need a protractor. If you've got your own, great. And I'd like you to do page 186, 187, numbers 1 to 5, and have some practice using your protractor. Okay, put your hand up if you need help. Don't forget. Okay, I want to describe some angles to you today. And program I use only lets me make my videos at 15 minutes max. So this might take more than one video. I might have to put 2 together. We'll wait and see. So first thing I want to talk about is what an adjacent angle is. An adjacent angle are angles that share a common vertex and a common arm. Let me draw an example here. So if I have a triangle right here, so let's say that this is angle C, and this is D, and this is B, and then I have a triangle like this, and this is angle A. So angle ABC, and the middle one is always the angle that we're referring to. So angle ABC there is adjacent to angle CBD. So again, it's the middle angle right here, and I'm going CBD like that. So you can see how they share a common vertex, which is right here, and common arm, which is CB. Supplementary angles are a little bit easier, and it's 2 angles. The sum equals 180 degrees. And then complementary angles is 2 angles whose sum equals 90 degrees. So those are probably 2 of the most important ones right here, supplementary angles and complementary angles to know about. Right angles, we know, are always going to be 90 degrees, and we know it's a right angle. I'm not sure if this is going to create a, no, of course not. Don't know why they don't give me a right triangle. Here we go. And do that. So a right triangle right there is always 90 degrees, and they will show you it's 90 degrees by putting that little box in there for you to know. Always. Okay? So if a right angle is split into 2 angles, they are, just as we talked about, complementary angles. And so those 2 angles are going to equal 90 degrees. Angles on a line equal 180 degrees, because a line, straight line, is 180 degrees. So if I have a straight line, such as this, and then I have some lines coming off of that, like that, and like that, all those angles, this angle, this angle, this angle, when I add them up, they will equal 180 degrees. Okay? So that kind of answers these two parts right here. Angles on a line will always equal 180 degrees. So, let's look at some examples here. It looks like I'll make it within my 15 minutes, which is great. So, this is 90 degrees right here. Okay? And this angle is 25 degrees. What is angle X? So angle X is going to be 90 minus 25, which is then going to be 65 degrees. Let's look at this next one. So if this is 90 degrees, and if this is 50 degrees, what's angle Y going to be? Well, that's 90. I know that this here is going to be 90 as well. So again, to find out what angle Y is going to be, it is going to be 90 minus the 50, which is 40 degrees. So you usually have to have information. If you're not given some information, then you're going to have to pull out your protractor. And so if I didn't know any of these angles on this third one right here, I would have to pull up my protractor and measure. Now I can't do that, unfortunately, on this tablet, but what I can do is we can do the math. I know these three angles are going to equal 180 degrees. So if I know that this one is 110, and this angle are the same, well, all three angles are 180, so I'm going to take 180 and subtract 110, which is 70 degrees. So that means this x and this x together equals 70. So all I need to do then is take the 70, divide it by 2, so each of those angles is going to be 35 degrees. Okay? I love doing this stuff, so please ask me some questions. I will come help you out, or Mrs. Notley will help you out, but I love doing angles. They're a blast. So try these out, page 189, numbers 1 to 4. If you do need a protractor, put your hand up and I will get you one. Okay, good luck.